And now going to part B. Part B says that we have Z2, part B, Z2, which is given as negative I minus 1. We illustrate it on the diagram. Yeah, by now you know how to draw. This is the real axis of Z2. This is the imaginary axis of Z2. When you come, the real part here is negative 1. So this is the origin. Negative 1, let me say it is somewhere here. That means the corresponding positive 1 is there. What is the coefficient of I here? The coefficient of I is also negative 1. That means it is approximately somewhere here. Negative 1, positive 1. Since they are all ones, they should be equidistant from the origin. But we are just estimating. Now let us draw the complex number. On the real axis, we have negative 1. On the imaginary axis, we need negative 1, which is here. So these two are going to intersect around here. They are going to meet here. Then you get your ruler. You draw a straight line. Is mine okay? Not really. This one should come. It's not easy to estimate this. That is very easy if you're using paper, because you have your lines there already. Something like that. Doesn't have to be perfect. That should be reasonable. That line there, put an arrow on top here. Then you say this is my complex number Z2. Now here we need to find the argument. Always, to make your work easier, I start by finding it anti-clockwise, because that is normally how we take the directions when we are using bearing in most cases. Now, from here it's already 90. This one is 90. Also, this one is 90. That means you have 180 already degrees. So here we need to just find this small angle. We add it to this 180, and then we judge. If it is in this range, we say it is a principal argument. If it is not in this range, then we find the other angle taken clockwise. So let me extrude this small triangle in that manner. The triangle looks like the triangle is in this format. There is that straight line, vertically downward we have got a line, and then the hypotenuse in that manner. Use a ruler so that yours is. So this is the small angle that we are looking for. Yeah, this is the small angle we are looking for. You can call it anything. Let me use beta again. That is beta. From here up to here is negative 1. That means it was just 1 unit. The negative shows where it is falling. It shows the quadrant. Also, from here up to here is negative 1, which is 1 unit. From here to down here is the same as from here up to here, which is also 1 unit. So this one is also 1 unit. Yeah, we have extracted everything. Now this is the angle. This is the angle we are looking for. So this is the opposite of the angle we are looking for. That is the opposite. And then this one here is adjacent to the angle we are looking for. This is where our right angle triangle forms. That is where the right angle triangle is. And then the longest side is hypotenuse. Hypotenuse. So then you go to your saw, saw. There is no hypotenuse. There is no hypotenuse. So you cannot use sine or cosine. But you can apply Pythagoras theorem to find the hypotenuse, and then you use either sine or cosine, and you get the same answers as somebody who used tan. So since we have adjacent and opposite, let us just use tan. Therefore, we shall say now tan of beta, which is our angle, is given by opposite over adjacent. That means tan of beta equals to opposite to the angle is 1. Adjacent to the angle is also 1. Therefore, tan of beta It's going to be 1 divided by 1 is 1. So now the angle beta becomes the arctan or tan inverse of 1, which is 45 degrees. Tan inverse of 1, tan inverse of 1, 45 degrees. So we have got this small angle, which was this small angle here. Now for us to get the argument, which we are measuring anti-clockwise, now here we now say argument, which we are not sure whether it is principal argument or just an argument. It's going to be argument theta now becomes that 45 degrees plus 90 plus 90, which is plus 180. This here now gives us, what does it give? It's giving us 225, something of that sort, 225 degrees. Now, after getting angle, then you come and compare it to the range of negative 180 to 180 degrees. Is it falling there? No. 225 is outside. It is more than 180 degrees. That means it is not the principal argument. Now, for it to be the principal argument, or for us to get a small angle that can fall in this range, it means we would measure it from here clockwise. We measure it clockwise there, so that it is smaller. Now, you don't need to waste time. Since you already know this side from here anti-clockwise up to where the complex number is, and you know the complete revolution, then you can just say it is 360 minus this other side that you have got, which is 135, degrees. But we are saying it is negative, saying that we measured it clockwise. So now here the principal argument, arc of Z2 is negative 135 degrees. But simply the only argument, or the argument alone, argument here still, argument of Z2 is the same as 225 degrees. These two angles point in the same direction. The only difference is the direction of turn. This one turns anti-clockwise. The other one, which is the principal argument, turns clockwise. That's why it is negative. So this is the solution to example 3. Let us go to, this is the solution to part B. Let us go to part C.